Widespread solar storms struck spacecraft near the Sun, Earth, and Mars in quick succession. And this is the solar flare that's coming out from NASA Stereo A Core 2. In 2021, a solar storm was recorded by multiple different spacecraft around our solar system. Their combined reading tells a curious story. Space weather may seem like a tale from a galaxy far, far away, but when solar storms impact us on Earth, we are directly affected. These storms are what give rise to the northern lights, for instance. They can even lead to temporary disruptions in our communication systems and power grid. And for these solar flares, we can learn so much from them. And a recent statement from NASA shares how back in 2021, one in particular had a brilliant story to go with it. As space agencies continue to send astronauts out into our planet's orbit and start planning for journeys even beyond, ways of monitoring solar storms and their impacts will become increasingly critical. These storms have the potential to harm humans, satellites, and spacecraft. A release from 2023 by the European Space Agency discussed how, for the first time, such energetic particles were simultaneously observed on the surfaces of the Earth, Moon, and Mars after a solar outburst. This raises important concerns. Widespread solar storms struck spacecraft near the Sun, Earth, and Mars in quick succession. Space radiation can create a real danger to our exploration throughout the solar system. Colin Wilson, ExoMars TGO project scientist, shared in the ESA's release measurements of high-level radiation events by robotic emissions is critical to prepare for long-duration crewed missions. In an era with a historic number of satellites and other instruments roaming through the great unknown, NASA's heliophysics missions use spacecraft to get a deeper understanding of space phenomena and tell the stories of what happens after solar events when particles are released into space. A recent article from NASA shares a perfect example of the efforts being made to study the impacts from solar storms originating from the light of all lights, the Sun. This solar outburst happened on April 17, 2021, and although these storms are not uncommon, with this specific event, the storm was so widespread that 6 spacecraft at different locations and positions felt this blast. High-speed protons and electrons, also known as solar energetic particles, SEPs, were observed by spacecraft not only between the Sun and Earth, but as far away as between Earth and Mars. According to NASA, this was the first time something like this has happened. We now have a whole different perspective on solar storms using data from multiple spacecraft versus a single one that can only provide a local insight. Let's use the famous Marvel hero as an example. Thor creates a solar storm to wipe out a bunch of bad guys, generating lots of SEPs to send out into space. He knows, however, that there are enemies on all sides, so he makes sure to create different balls of these SEPs that can go in all different directions, covering a much wider territory than a single beam can. With more eyes on a single event, we can better understand all of the different types of hazards that can come from one solar storm, which can sometimes pose a threat across a larger playing field. SEPs can harm our technology, such as satellites, and disrupt GPS. Anina Dressing of the Department of Physics and Astronomy, University of Turku in Finland, said in the NASA statement, also, humans in space or even on airplanes on polar routes can suffer harmful radiation during strong SEP events. Dressing and her team conducted further research from the event to learn where the SEPs came from and how the particles revved up to dangerous speeds and when they made contact with each spacecraft. The conclusions plotted on the diagram were as follows. The closest to the blast, which took the blunt of the blow, was the Bepi Colombo spacecraft, a joint mission of the European Space Agency and Japan's Space Agency JAXA. Bepi Combo is en route to Mercury. The second hardest hit by particles was NASA's Parker Solar Probe, which sits extremely close to the Sun, and that's what followed by ESA's Solar Orbiter. Parker and the Solar Orbiter were on opposing sides of the flare when it happened. A little closer to home, NASA's Solar Terrestrial Relations Observatory, STEREO for short, the Stereo spacecraft Stereo A, the NASA ESA Solar and Heliospheric Observatory SOHO, and NASA's WIND spacecraft were hit by the event. Finally, the farthest away final spacecraft to detect particles from the blast were Mars orbiters, NASA's MAVEN and ESA Mars Express. By determining their differences in location from around the Sun and noting how many electrons and protons were observed by each spacecraft, Dressing and her team were able to paint a much clearer picture of what happened from the solar ejection. Multiple sources are likely contributing to this event, explaining its wide distribution. Georgia Denolfo, team member and heliophysics researcher scientist at NASA's Goddard Space Flight Center in Maryland, said, "It also appears that from this event, protons and electrons may come from different sources. This is not the first time that people have conjectured that electrons and protons have had different sources for their acceleration. This measurement was unique in that the multiple perspectives enabled scientists to separate the different processes better to confirm that electrons and protons may originate from different processes." As we know, this will not be the last time an event like this occurs, and the more research we can do, the better understanding we can have of what happens with space weather, and the more we can cautiously explore the final frontier. Future studies that stem from these results will cover a wider terrain of other phenomena, and they'll be conducted by instruments including the Geospace Dynamics Constellation GDC, the Sunrise, Punch, and Helioswarm. The study was published last year in the journal Astronomy and Astrophysics, originally published on space.com. And this is on Live Science by Meredith Garofalo. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.